The ancient Greeks believed that these four elements was what everything was made up of: water, fire, earth, and air. The elements were pure but could not be found in that state of earth. Every visible thing was made up of some combination of earth, water, fire, and air. Democritus believed that there was such a thing as an atom, but the main philosophy of the time disagreed. Although elements such as gold, silver, tin, copper, lead, and mercury have been known since earliest times, the first scientific discovery of an element occurred in 1649. Hennig Brand, a German alchemist, treated urine to a series of processes that resulted in the production of the element phosphorus. The Russian chemist Mendeleev was the first scientist to make a periodic table, similar to the one used today. Mendeleev arranged the elements in atomic mass corresponding to the relative molar mass. Scientists over time were able to recognize the patterns and the properties of these elements, leading to developing the periodic table. Mendeleev created the periodic table and arranged the elements in order of relative atomic mass.
Scientists have used the scientific method over time to explain the model of the atom. One of the experiments was Dalton's experiment. In this experiment, he tested and measured the amount of water vapor that air could absorb at different temperatures. So over here, he heated up some water and it traveled through a tube, and he measured how much of the water vapor was absorbed into the air. This also eventually led to Dalton's law of partial pressure. This resulted in discovering that the total pressure of a mixture of gases adds up to the sum of partial pressures that each gas is exerting while they are occupying the same space. So atoms within a mixture varied in weight and complexity. Also, another scientist was Rutherford. His experiment was known also as the Geiger-Marsden experiment and Rutherford gold foil experiment. So what happened was he demonstrated the composition of atoms by aiming a beam of alpha particles, which is right over here, through a very thin gold foil, which is over here, and a screen. And they found out that the atom is mostly empty space, and the nucleus is positively charged, and the nucleus carries most of the atom's mass. So what this also resulted in is that most particles went through the gold foil, but some of them were deflected. And when most of the alpha particles went through, it showed that the atom contained mostly empty space and that it had a very dense nucleus, which is the center of the atom. The discoveries that were found by both Rutherford and Dalton in these experiments helped scientists discover what the model of the atom actually looked like.
Welcome back to Crash Course. Now we're going over the development of the model of the atom. The first model was made by Dalton, who viewed atoms as tiny solid balls. Then J.J. Thomson came along and he said that atoms are made mostly out of positively charged materials, like a dough and a bun. Then Ernest Rutherford discovered that protons are in the nucleus, and that, so his big contribution was that protons are in the nucleus, and that there was a nucleus. First idea. And then Niels Bohr then proposed that there were electrons that moved around in shells outside the atom. And then Chadwick came along and was like, hey, we have neutrons who have no charge. And then now the modern model is a mix. We have the electrons on the outside, and then we have a nucleus with protons and neutrons. That is it.
Many scientists contributed to the model of the atom. For example, Becquerel was the first person to conclude that atoms could be radioactive. He placed uranium salts on top of a photographic plate wrapped in black paper. With Bohr, he created the Bohr model, which was a model easily seen an atom and the charges of what it has. The model clearly shows how many protons, electrons, and neutrons are in an atom and their atomic number. Curie she was from France, and while keeping Becquerel's study in mind, she discovered that elements radiated some sort of energy, which is radioactivity. It was the amount of radiation dependent on the amount of element present in a compound. Radioactivity does not depend on how many atoms are arranged into molecules, but it comes from the atoms themselves. Most important scientific contribution. Elements may change into another element naturally due to instability, and she discovered radium and polonium.
Other scientists that helped contribute to the atom was Chadwick. He discovered the neutron, also found in the nucleus, in 1932. He discovered this by using a neutron chamber in his experiments. He worked alongside Rutherford, and he discovered particles with no charge. Dalton also contributed. His atomic theory consisted of multiple ideas still used today. First, all matter is made of atoms, which is indivisible and indestructible. Second, all atoms of a given element are identical in mass and properties. Third, compounds are formed by combining a combination of two or more different kinds of atoms. A chemical reaction is a rearrangement of atoms. And last, atoms cannot be created or destroyed. Dalton used experiments with gases to discover his theory. And next is Crookes. Crookes is responsible for reconstruction of the cathode ray. He discovered the element thiolum and shows that there is negative charge in atoms.
Other scientists that contributed were Millikan, who did the oil drop experiment that helps to quantify the charge of an electron, used to determine the charge of a single electron. He designed his experiment to measure the force on oil droplets between two electrodes. Another scientist was Thomson, and he discovered the electron in 1897, and he also proposed the plum pudding or raisin bud model of the atom in 1904 before the discovery of the atomic nucleus in order to include the electron in the atomic model. In simpler words, the first scientist to show that the atom was made of even smaller things, as well as proposing the existence of a positive particle. The last scientist is Rutherford, and he's known as the father of nuclear physics. He discovered alpha and beta rays, set forth the laws of radioactive decay, and he identified alpha particles as helium nuclei.
This has been Crash Course of the Model of the Atom.